Welcome to Lab 4, Oscillations, and let's get right into it. So first things first, the task of this lab is to use the given experiment video of a mass on a spring that oscillates over a period of time to create a model that predicts this motion. We're going to use it to answer a question about the energy principle and about the period of oscillation. And so what do we exactly need in order to do that? We actually are going to be using the energy principle. So we're going to be using, most importantly, things acting on the system's energy. So that'll be made up of kinetic energy, gravitational potential energy, and the spring potential energy in order to create the total system's energy. We will also be using the position update formula in order to track the change in position of the mass over its period. So how we went about this was to take the mass on a spring, plug it into tracker, and I would go frame by frame, following the mass as its positions change, and then taking the X and Y positions that we got from that and plugging it into an Excel, turning that into a CSV file that we then can compare with our model eventually in the code. So for the code itself, we want to follow the energy principle and the mass as its energy changes, and so we want to track these things, plugging them in. You can see that these separate things will be tracked and followed to create graphs in the end that we will then compare with our CSV file that we got previously in order to see if we were successful or not. Once we get those graphs, we want to be able to use this data to answer our questions. So the first question actually is to see if our model system that we end up creating, if it follows the energy principle and the conservation of energy. And what's most important that we got out of our data is this change in energy versus time graph. And that's because the delta E, or this orange line here, is our change in energy over time. And as you see, it is just a flat line at 0. It means that it does satisfy the energy principle because energy, although kinetic energy and spring potential energy and gravitational potential energy change, the actual energy of the system stays the same. At 0, or the delta E is 0, so the E is constant, and energy is conserved. For the second question, we want to take that video we got and the data we obtained in tracker to make two separate estimates using the separated components of the X and Y of the periods of oscillation, and then create periods of oscillation with these. You can see that they're very, very, very similar, but just barely different. And this is because the X and Y components are affected more so by different types of energy, so spring potential energy and gravitational potential energy, and that causes that small variance. Thank you so much, Dr. Munoz, for the class. You had a lot of patience with us and were very communicative and helpful, and just want to say thank you. Appreciate it. Have a good day.